All right, so let's walk through this question on preferences from a past exam. So as with all these videos, we're going to solve the question. I'll point out how I'm parsing the language and how I'm thinking through the solution as I go about solving it and any decisions I'm making along the way. So here we go. Each scenario below describes a different set of preferences for bundles of apples and oranges, A and O. For each scenario, let's draw an indifference curve passing through the bundle 5 apples, 5 oranges, consistent with the description. Also give the numerical value of the slope of the indifference curve at the bundle 5 apples, 5 oranges. All right, so what do we need to be doing here? Well, we need our indifference curve. We also need that numerical value for the slope. So that's what we want in each one of these scenarios. Let's move on to our first scenario here. So Arnold always consumes apples and oranges together in a fruit salad. His recipe for fruit salad calls for 1 orange for every 2 apples. So let's go ahead and make note of that. So 1 orange to every 2 apples. He always follows the recipe and gets no enjoyment out of apples or oranges unless they're in fruit salad. So he's always going to use this 1-to-2 ratio. That means I'm in my perfect complements world. All right. So if I've got perfect complements and I always combine them in this 1-to-2 ratio, these are going to be my L-shaped indifference curves. And the corners are going to be where I have that exact right ratio. So if we think about having 5 oranges here, right? 5 oranges would need 10 apples to make my fruit salad, right? This 1-to-2 ratio. And so that would be way out here somewhere. So it's actually going to be the apples that's constraining me here. And so if I have 5 apples, the most I can consume in terms of oranges is going to be at 2.5, right? And so that would be how many oranges I would use for those 5 apples. So that's part of my indifference curve here. And then the rest would extend out that way. So at that point of 5, 5, my slope there is simply 0, right? Because an additional orange isn't helpful to me. It's apples that are constraining me at that point. All right, so let's move on to part B here. So Betsy likes apples but dislikes oranges. So let's go ahead and take note of that. Apple's good, right? Orange is bad. All right, every apple she consumes increases her utility by 10 utils. So I'm going to say my margin utility of an apple is 10. Every orange she consumes decreases her utility by 20 utils. So my margin utility of an orange is minus 20. All right, so here we've got constant margin utilities. So every time I make her have an extra orange, that decreases utility by 20, right? So if I move over by 1 orange, utility goes down by 20. I would need to add 2 apples to make up for that, right? So every time I go over by 1, I have to go up by 2. Over by 1, up by 2. So this is going to be a straight line, right? Where every time I go over by 1, I'm going up by 2. So it has a slope that's equal to 2. All right, one more to go here. Carl's utility from apples and oranges is given by the utility function u of a and o is a plus o squared. All right, so we want the indifference curve passing through the point 5, 5. All right, we know that for an indifference curve that's nice and smooth and convex and well behaved, the slope is just given by the marginal rate of substitution. So let's go ahead and figure that out. Well, that's minus the margin utility of the horizontal axis good, so in this case O, over the margin utility of the vertical axis good, which is A. So that's going to be minus the derivative of the utility function with respect to O, which will give me 2O, over the derivative of the utility function with respect to A, which is just going to give me 1. And so this thing is just equal to minus 2O, right? So at this point of 5, 5, that's going to be minus 2 times 5, which is negative 10. So in this case, we know that the slope at that point is equal to negative 10. Now we still need to figure out what the shape of this indifference curve looks like. First of all, it's going to be downward sloping, right? We have a negative marginal rate of substitution. I could also just notice that both of these are goods, right? So we're going to have a downward sloping indifference curve. The other thing I can notice is that my marginal rate of substitution ended up being negative 2O, all right? So as O gets bigger, as I move from left to right, that magnitude is getting steeper. O is getting larger. So my indifference curve is getting steeper. So it's got to be a concave shape here. And there we go. That was our preferences problem.